Hi, welcome to my channel. In today's episode, we'll be solving this problem related to probability. And the question reads, a pair of die is rolled once. What is the probability of obtaining a prime number or a number greater than 5? So in probability, there are keywords we need to look at. We should be very, very mindful with that word. Anything that has to do with when they say O, and we should be mindful with these two words. O means addition and means multiplication in probability. So now they said the probability of obtaining a pair of die. We all know what a die is. A die we use a die to play our games, our daily games with. So now that pair of die is being rolled once. They roll it once. And we know a die has 6 spaces. A die is something like this with 6 spaces. So the first space has only 1 dot, the second space is 2 dots, the other space is 3 dots, another space has 4 dots, another face has 5 dots, and then the last face have 6 dots. So now these are the die, these are the faces of the die. It has 6 faces, 1, 2, 3, 4, 5, 6. So now these are the 6 faces of the die. We all know what the die is. So now they say the pair of die is rolled once. They only roll it once and throw it. So now they say, what is the probability of obtaining a prime number? So now we need to define what a prime number is. What are prime numbers? If you know the answer, drop it on the comment section. Now, a prime number are numbers that have 2 factors, 1 and itself. Any number that has 2 factors, that's the easiest way you can define a prime number. Any number that has 2 factors, 1 and itself, is called a prime number. For example, I have 2. What can divide 2 apart from 1 and itself? What can divide 3 apart from 1 and itself? What can divide 5 apart from 1 and itself? So what other prime numbers do we have within this range? It's either 1, 3, 2, 3, 5. 6 is not a prime number, 4 is not a prime number, right? 2 can divide 4, 1 can divide 4, 4 can divide 4. So it has 3 factors here. 1 is also not a prime number because we said one of the characteristics for it to be a prime number, it must have 2 factors, 1 and itself. So now the factor of 1 is 1. Apart from 1, you cannot have any number. So therefore, 1 is not a prime number. Now, going back to our question, so we have only 3 factors, 3 prime numbers. So now, the prime numbers, probability of obtaining a prime number is going to be, the prime number are set of 2, 3, and 5. So now these are the set of prime numbers we have within this event. Then O, they said O, a number greater than 5. What number do we have that is greater than 5 within this event? It must be within this range because we roll the die only once. Had it been is twice, then we can have 2 of 5, we can have 2 of 6, we can have 2 of 4, 2 of 3. But it is being rolled once. So now these are the possible number of occurrence after rolling the die once. So now anything we are obtaining or we are fetching, it must be between these sets. So now this is our universal set now. The universal set comprises of all these numbers. So whatever we are picking has to be from this universal set. So now the probability of picking a number greater than 5 is going to be what? 6 is the only number that is greater than 5, right? Apart from 6, we don't have any other number that is greater than 5 within this universal set. So therefore, this is going to be a set of 6. So now, going back to our question, they said we should find the probability of obtaining a prime number or a number greater than 5. So now, the probability of picking a prime number is what? Probability of picking a prime number is going to be what? Probability of picking a prime number, we said, defining it using the classical concept of probability, is the number of occurrence of the possible outcomes of the event divided by the total number of outcomes. So now, what is our total number of outcomes? This universal set. 1, 2, 3, 4, 5, 6. 6 is our total number of outcomes. Then the possible number of outcomes of this event, which is the prime number. So now I'm dealing with this prime number now as an event. What is the total number? The possible number of outcomes is 1, 2, 3. So I have 3 of these prime numbers. So it's going to be 3 divided by the total number of outcomes, which is 6. So 3 over 6, 3 here is 1, 3 here is 2, is 1 over 2. The probability of picking a prime number is 1 over 2. And the probability of picking a number greater than 5. Probability of picking a number greater than 5 is 6. The element here is 6. This 6 is not the number. This 6 is an element of the set. So now 1 is the number. So now the possible number of outcomes of this event is 1, is not 6. Unlike this one, you don't say it's 2 plus 3 plus 5. It's never like that. We just read the entries. These are the entries, or these are the elements of the set. So now we read the element. There are 1, 2, 3. We have 3 total number of outcomes of the event A. Number of outcomes favorable to the occurrence of an event B now is 1, because 1 is the only element. 1 is an element. The only element within that set is 1. We're not dealing with the 6. So this is 1 over the total number of possible outcomes of the event, which is this one, is 6. 1 over 6. So this is 1 over 6. But remember, they said prime number or a number greater than 5. So this is going to be probability of picking a prime number or probability of picking a number greater than 5. So now the prime number we said is 1 over 2 plus probability of picking a number greater than 5 is 1 over 6. I can say this is the same thing as 3 over 6, so that I can have a uniform LCM. It's still the same thing. Yeah. So now add these two numbers. The LCM here is 6. This is going to be 3 plus 1. This is going to be 4 over 6. 2 here. 4 here is 2. 4 here. 2 here is 3. So this is 2 over 3. As the probability of picking a prime number or a number greater than 6. If you find this interesting, please do me a favor by liking my page, sharing this video, and give us a thumbs up. If you have any question, drop it on the comment section. If you have any subject that you want us to teach in the next episode or in the next tutorial, kindly recommend or write it on the comment section. I will see you some other time with another exciting episode on Math with Kantoma. Thank you.